Welcome! In this video, I'm going to walk you through the scripts included in this Unity package. You can find the link to the asset store right down in the description. This will be a quick guide to help you configure the project and solve any initial setup errors. Let's start by opening the example level. First, this project relies on two essential Unity packages, AI, Navigation and Text Mesh Pro. AI, Navigation is fundamental because both the player and enemies rely on the nav mesh for movement. Text Mesh Pro is required for the visual feedback system, specifically the floating damage numbers. Next, we need to configure your layers. For enemies, create a specific layer, for example, enemy. You must go into the player auto shooter, toxic trail emitter, and player lightning caster components and set their target mask to include this layer so they know what to attack. For obstacles, select your environment objects, like walls, and assign them to an obstacle layer. Then, in the player scripts, specifically player auto shooter and player lightning caster, make sure to select this layer in the loss obstacles field. This ensures the line of sight logic works and walls actually block shots. Finally, check the top-down nav mesh input controller on your player. You need to explicitly assign the move action from the new input system into the move action reference field for the character to start moving. Now that the setup is ready, let's break down each feature. Now, let's look at the automatic offensive components, designed to easily create survivor-style auto attacks. First, the player auto shooter functions like a turret. It automatically acquires targets within range and fires using the values from your player weapon stats component. A key tip here is to use the head tag field. If your enemies have a specific bone tagged, e.g., head, the shooter will aim there instead of the root for better accuracy. Next, the player lightning caster handles periodic magic bursts. It selects multiple targets at once based on the bolts per cast setting and applies instant AoE damage. You simply need to assign your beam and explosion VFX prefabs in the inspector to visualize the attack. Finally, the toxic trail emitter drops damaging clouds behind the player. This script is movement aware. Use the min distance between spawns value to ensure clouds are only dropped when the character has actually moved, preventing infinite stacking when standing still. All three components automatically respect your project's friendly fire and team settings. At the core of your character's survival, we have the health component. This is an all-in-one solution that handles damage, death logic, and even passive regeneration. A standout feature here is the built-in UI integration. You can simply drag a UI slider into the inspector, and the script automatically handles value smoothing and color gradients. You should also tweak the invulnerability seconds field, which gives players a brief safety window after taking a hit to prevent instant death from overlapping enemies. Powering your attacks is the player weapon stats component. This acts as the central data hub for your offensive capabilities, defining fire rate, damage, and knockback. It allows you to create different weapon archetypes easily. For example, by increasing projectiles per shot and spread angle, you can instantly create a shotgun effect. This script also includes helper methods like add % damage, making it ready to hook up to your level up system immediately. To manage character progression, use the player level manager. This script handles experience points, leveling logic, and critically, the pause on level up feature, which is essential for presenting upgrade choices to the player. You can fully customize the XP progression curve in the inspector. Choose Exponential for standard RPG scaling, or Fixed Table, if you want to manually define the exact XP needed for every single level. The manager also includes built-in Unity events on level up and on XP changed, making it effortless to link your UI bars and upgrade menus without writing extra code. To handle your ranged attacks, we use the Projectile homing component. This is a smart projectile that chases a specific target transform, ensuring your shots land even if the enemy moves. Crucially, it supports piercing, allowing shots to pass through multiple enemies, and wall detection, destroying the projectile if it hits the environment. It also shares the same friendly fire logic as the other components, so your homing missiles won't accidentally target your allies. Just assign your impact VFX, and the script handles the rest. The wave structure. At the heart of your game loop is the wave spawner. Think of this as the game director. Instead of a simple list, it uses a flexible nested structure. You create a wave, and inside that wave, you can add multiple entries. This allows you to mix and match enemy types. For example, a single wave could consist of 10 basic goblins spawning quickly, and one boss spawning after a delay, all managed within the same block. Part 2. Spawning Logistics. To ensure your enemies never get stuck inside walls, this component features smart nav mesh sampling. Even if your spawn points are slightly off-map, the nav sample radius will automatically snap the enemy to the nearest valid walkable surface. You can also use the spawn scatter radius to add randomness to the positions, so enemies don't stack perfectly on top of each other when spawning in groups. Part 3. Flow and Difficulty Scaling. Finally, you have total control over the game's pacing. You can check wait until cleared to force the player to defeat all enemies before the next wave starts, or uncheck it for a chaotic, timer-based survival pressure. For endless modes, simply enable loop waves. The spawner effectively replays the list indefinitely. You can even use the loop count multiplier to automatically increase the number of enemies with every successful loop, creating an infinite difficulty curve without any extra coding. And don't worry about performance. The Max Alive setting ensures you never exceed a specific number of enemies on screen at once. To orchestrate your interface, use the UI Manager singleton. It acts as a central registry for all your UI panels, like the HUD, pause menu, or level up screen. Instead of manually dragging references everywhere, panels register themselves with a unique ID string. You can then simply call UI Manager, instance, show, panel ID, from anywhere in your code to open a menu. The manager automatically handles the mouse cursor, locking, unlocking it based on whether a menu is open, and game pausing via a smart reference counter, ensuring the game only unpauses when all blocking menus are closed. It even attempts to auto-connect to the player level manager to trigger your upgrade screen automatically on level up. Here is the functional explanation for the upgrade manager. This is the logic that turns math into fun. Finally, we tie everything together with the upgrade manager. This component acts as the bridge between your level manager and your offensive systems. In the inspector, you populate the all upgrades list with your upgrade assets. When a player levels up, this script performs a weighted roll to present a set of options. You can customize how many choices appear using the options per level field. Crucially, it includes smart filtering. It automatically hides upgrades that have reached their max stacks or that conflict with a previously chosen build. Once a player chooses an option, this manager handles the math, applying either flat or percentage modifiers directly to your weapon stats, lightning caster, or toxic emitter without requiring custom code for every new item. Here is the functional explanation for the data assets, completing the progression system. To populate your catalog, you create upgrade definitions as scriptable objects. Each asset represents a specific card the player can choose. In the inspector, you set the display name, icon, and description for the UI, along with the weight to determine how rare the upgrade is. The magic happens in the modifiers list. Here you define exactly what changes, whether it's adding flat damage to a weapon, multiplying the player's speed, or increasing the radius of the toxic cloud. You can even combine multiple modifiers in a single asset to create complex, legendary upgrades. To give players satisfying feedback when they land a hit, we use the damage number system. To ensure high performance even with hundreds of enemies on screen, the damage number pool pre-instantiates these effects upfront, eliminating memory garbage during combat. The visual behavior is controlled by the damage number component. It handles the pop-in, animation, and upward drift, but the most important setting to tweak is dynamic scaling. By setting a reference damage for normal hits and a high damage for critical hits, the system automatically scales the text size based on the damage amount, making your heavy attacks feel significantly more powerful visually. It also automatically billboards to face the camera, ensuring text is readable from any angle. And that's a wrap. Just a quick reminder that you can find the link to this package on the Unity Asset Store in the video description below. If you decide to pick it up, please consider leaving a review. It really helps the package grow and supports my work tremendously. I've also included a link to my Discord server down there. Feel free to join if you want to propose new features, report any bugs, or just need some personalized support. I really hope you enjoy using this asset in your projects. If you need anything, I'll see you on Discord. Thanks for watching, and happy developing.